Zeros are generally represented using Greek symbols like alpha, beta, gamma, etc. Now we will look at the general form of a quadratic polynomial, which is ax squared plus bx plus c. Let alpha and beta be the zeros of this polynomial. Notice that the degree is 2 and the number of zeros is also 2. If alpha and beta are zeros of a polynomial, then we can say that x minus alpha and x minus beta are factors of that polynomial. So we wrote this polynomial as this factor multiplied by this one. Now we are about to derive something really interesting. We will find a relation between the coefficients of the quadratic polynomial ax squared plus bx plus c and the zeros of the polynomial. Basically, find a relation between alpha beta and abc. Remember, we are assuming that alpha and beta are zeros of ax squared plus bx plus c. We use the distributive law to solve the right-hand side. It equals x multiplied by x minus beta minus alpha multiplied by x minus beta. We multiplied this with this and this with this. Solving the first group, we get x squared minus beta x, and solving the second group, we get minus alpha x plus alpha beta. These two terms have x as their common factor. Taking x common from both these terms, we write the equation as x squared minus alpha plus beta multiplied by x plus alpha beta. Now this is in the form of ax squared plus bx plus c. So we can equate the coefficients of each of the terms of these equations. The coefficient of x squared is 1, so we can say that a equals 1. The coefficient of x is minus alpha plus beta, so b equals minus alpha plus beta. And the constant term is alpha beta, so we can write c equals alpha beta. So we have successfully found the relation between the coefficients of a quadratic polynomial and its zeros. But let us go one step further. We divide b by a. Don't worry, you will soon know why we are doing this. b is minus alpha plus beta and a is 1. It equals minus alpha plus beta. Taking this minus sign to the other side, we can say that alpha plus beta is minus b by a. Now you're probably getting a hint of what we are up to. This is the sum of roots. Let's go another step further. Now we divide c by a. c is alpha beta and a is 1. This equals alpha beta. Now we can say that alpha times beta equals c by a. Why did we do this? With this, we got the relation between the sum of zeros and coefficients and also the relation between the product of zeros and the coefficients. So let's analyze the sum of zeros. In the numerator, we have minus b, and b is actually the coefficient of x. We can write the numerator as minus coefficient of x. The denominator is a, which is the coefficient of x squared. So we write coefficient of x squared in the denominator. So the sum of zeros will always be equal to this ratio. In a similar way, let's find the product of zeros. It is c by a, and c is actually the constant term. A is the coefficient of x squared. So we write the product of zeros as constant term by coefficient of x squared. Once we find the roots of a polynomial, we can use these formulae to verify our answer. We zoom out a bit and verify these relations for the polynomial which we saw in the previous video. We found the zeros of the polynomial x squared plus 5x plus 6 by factorization. They were minus 2 and minus 3. First, let us find the sum of zeros. It's minus 2 plus minus 3. That equals minus 5. Now let us find minus b by a. In this polynomial, b is 5 and a is 1. So we get minus b by a as minus 5 by 1, and that equals minus 5. So our answer matches this value. Let us find the product of zeros now. It is minus 2 multiplied by minus 3, and that equals 6. And to verify, we find c by a. c is 6 and a is 1, so it equals 6 by 1, which also equals 6. So this can be one way to check our answers. Once you get the zeros, try finding out minus b by a and c by a to verify your answer.